All right, so we think we know how to find the derivative of a lot of different functions, but actually we've just touched on the surface. What if I ask you to find dy dx for y equal 3x minus 4 quantities squared? What are you going to do with that? Well, you might think the power rule, so y prime, or dy dx, I just multiply the 2 out in front, and then I subtract 1, and it just becomes 3x minus 4 to the first. And then if I distribute that, I get 6x minus 8. But wait a minute. What if, instead of doing that, I multiplied this out? And so I had y equal 9x squared. Minus 12 and minus 12 is minus 24x plus 16. And now if I take the derivative, 2 times 9, I get 18x to the first, and then minus 24. That's not the same. Something's wrong. Well, I know that I multiplied this out correctly, and I know I applied the power rule correctly, so this is the correct answer. So why didn't this work? So the power rule said that if we have x to a power, then the derivative with respect to x is going to be n times x to the n minus first power. But here, we don't just have x as our function, we have a more complicated function involving x. And so what do we do with that? And so therein lies the idea behind the chain rule. But before we talk about the chain rule, it's important to revisit composition of functions. So let's take a look at that for a minute. Find f of g of x if f of x is x cubed and g of x is 2x minus 1. So if you remember, for composition, you take that inside function and then you plug it in to the outside function. So wherever I see x, I'm going to plug in 2x minus 1. So the composition is going to be 2x minus 1 to the third power. And then you could expand that if you wanted to. Let's try a few more. Find the composition if f is sine of x and g of x is 5x squared. So I'm going to send 5x squared into f and take the sine of that. So I'm going to be taking the sine of 5x squared. Okay? And by the way, as I always say, it's a good idea to hit pause, write down your answer, and then compare. Okay, this time be careful. G of f of x. So now we're going to take f and we're going to plug that in for x in the g function. So g says take e to the power of whatever the input is, and the input is x squared plus 7. Find s of t of x. So I'm going to take 5x plus 2 and send it to my s function, which does the reciprocal. So 1 over whatever you send it, in this case 5x plus 2. All right, what if we worked backwards? What if I told you this is the composition, what were the two functions I started with? Well, when I look at this, I think, oh, I have something to the third power. So my g of x, I could let equal x to the third. And then f of x is going to be x squared plus 4. So when I send f to the g function, it'll cube x squared plus 4. Now that's one possibility. There's countless possibilities for this, but that's probably the most straightforward. Let's try another one. Find f and g of x for this one. So g of f gives us that. So when I look at this, I think, oh, the g function is 1 over whatever the input is. So that would be an easy way to go. I'll let that be 1 over x. And then f of x, I'll let that equal to 7x minus 2. So that's another possibility. Let's try one more. How about this one? Well, I look at the outermost function. To me, looks like it's just the square root of something. So I'm going to let g of x equal the square root of x. And then f will equal 3x squared plus 1. The nice thing is you can take your answer and then just do the composition of those and make sure you get what you started with. Okay, so it's important when you look at more complicated functions like this, that you see the composition of functions, because that's what we need to do in order to apply the chain rule. So first, there's a few practice problems in 12.b1, and after you do those, you're ready to go on to the chain rule. Okay, so the chain rule, I'll give you the formal definition, but then I think the best way to understand it is to try some problems. So if y is a function of a variable u, and then u is a function of another variable x, then y would be the composition of those two functions. And so we could say that y is a composite function of x. And then to find the derivative of y with respect to x, is we're going to take the derivative of y with respect to u, and then multiply that by the derivative of u with respect to x. Seems kind of complicated. It actually isn't at all. Here's another way to state it. If y is equal to g of u, and u is equal to f of x, then to find dy dx, we're going to find dy du, which means we're going to find the derivative of this g function, and then we're going to find du dx. That means finding the derivative of this f function and multiplying those two together. So like I say, examples will make it much more clear. So when I look at this, I see two functions. I see that I have something squared, and then that's something. So to find dy dx, first you have to look at the outermost thing. And here's one way to think about it. I talk about in the innermost, the outermost functions. The outermost function, if I asked you to evaluate this, and I said, okay, evaluate it for x equals 2, what would you do first? You would multiply by 3 and subtract 4. Then when you got that answer, you would square it. So the last thing you did, that's actually going to be the first thing we'll start with for our derivative. So what's the derivative of something squared? Well, it's 2 times something to the first power. So that's the first part. Then times, so now we've taken care of the x squared function. Now we have to do the derivative of the inside. What's the derivative of 3x minus 4? That's just 3. So I can go ahead and multiply and distribute everything. I'm going to get 18x and then minus 24. Wait a minute. 3x minus 4 squared, that was our opener. And 18x minus 24 is what we got. So that's how you apply the chain rule to these types of problems. Let's try some more. How about the derivative of this one? So you want to look at this and see two different functions. So I see this as 2 times x squared plus 1 to the negative first power. So first I want to take care of the outside function, and that's the negative first power. So the derivative of that with respect to x is going to be negative 1 times the 2, and then x squared plus 1, and we subtract 1, so it's going to be the negative second power. Okay, so I've taken care of that negative first power. Times, now I have to take the derivative of the inside function, and that's just going to be 2x. So my final answer is negative, and actually I'm going to write it as a fraction. You don't have to, but it would be negative 4x over x squared plus 1 quantity squared. If you want to leave it as a negative exponent, that's fine. Okay, let's try another one. How about sine of x squared? Well, that seems pretty simple. But there's actually two functions here. I see the sine function, and then I see the x squared function. So to find the derivative, what's the derivative of the sine of something? Well, that's the cosine of something. And then, so I've taken care of the sine function. Now what's the derivative of the inside part? That's 2x. And so there's your answer. You might want to write it in a different order, but it doesn't really matter. And there's your derivative. So the chain rule is a very, very powerful tool when you have more complicated functions, especially when you look at them as a composition. So when you look at this, what do you see? We've got the natural log of something, and then within that, we have a cosine plus an x cubed. So let's start with the derivative of the natural log of something. And that would be 1 over something. So 1 over the argument. Okay, and then the chain rule, so times, so we've taken care of the natural log. Now let's take the derivative of the inside, and I'm going to need parentheses here. The derivative of cosine is negative sine, and the derivative of x cubed is 3x squared. So if you want to clean it up a little bit, I guess I would write it as one fraction and say negative sine of x plus 3x squared over cosine of x plus x cubed. Hopefully you're getting the hang of this. Later on, we're actually going to work backwards and start with something like this and figure out what the original function was. That probably sounds like a lot of fun. Okay, how about this one? What functions do you see? You see a sine of x and you see e raised to a power. E raised to a function of x. So first, let's take care of e to the something power. So dy dx, if it was just e to the x, the derivative would be e to the x. But in this case, it's e to the sine of x. So I've taken care of the e to a function of x derivative. And then the chain rule says now multiply by the derivative of the other function, and that would be cosine of x. And that's it. Now one nice thing you can do is you can actually graph the original function in y1 on your calculator, and then in y2 graph the derivative of y1 and make sure that the graphs match. Later on we can talk about some domain restrictions. Alright, so how about this one? Well, first of all, maybe we should see this as an x to the 4th minus 6x to the 1/2 power. Now we'll find dy dx. So that'll be 1/2 something to the 1/2 minus 1 is negative 1/2 power. So I've taken rid of the square root function. I did that derivative. Now let's do the derivative of the inside part. And that's going to be simple using the power rule, 4x cubed minus 6. And so if you want, we could actually factor a 2 out of that. And so I would wind up writing it as 2x cubed minus 3 over the square root of x to the 4th minus 6x. Could you leave it as a negative exponent instead? Sure. All right, hopefully you're getting the hang of these. Let's try one more. Wow, there's a lot going on here. So remember back when I said, how would you evaluate this? If I said x is equal to, let's say, 1, what would you do first? You would do 2 times 1. So that's the innermost function. Then what would you do? Well, you do e to the 1st power. That's the next function. And then what would you do? You would take the sine of that, and then what would you do? Then you would square that. So there's actually 4 functions here. There's 4 things going on. So we're just going to break them down one piece at a time and use an extension of this chain rule. So dy dx. Let's start off, get rid of that. Let's start off with, what's the derivative of something squared? Well, that would be 2 times something to the 1st power. All right, I've gotten rid of the squared part. Next, chain rule says times. What's the derivative of the next thing? The next thing is the sine function. And so that's going to be the cosine of whatever. So now I've taken care of the sine. Next, I have e to something. What's the derivative of e to something? It's e to something. Taking care of the e function. Finally, times. What's the derivative of 2x? That's just 2. And so now, so you see how I've worked my way from the outside all the way in. It's kind of the opposite order of how you would evaluate. So I would probably write this as 4 e to the 2x sine e to the 2x cosine e to the 2x. And if you remember some of your sum and difference formulas, there's actually a way we could break this down, because 2 sine cosine is sine of 2 theta, but I won't boggle your mind with that right now. We'll just leave it like that. So there's some problems then in 12.B2.